So welcome everyone. My talk, Unify Cohort Creation Workflow with cohortBuilder and System. I'm Krystian. I'm R and Shiny developer at 7M. I've spent many years working with data scientists and actually helping them to make their work with data easier. So here is what I observed. Something is not rendered properly. Annie, okay, let's stay with that. So the standard data scientist in an organization needs to work with various data sources, so data frames, SQL database, even the local file or the REST API. More to that, he has to work with different data models. Like sometimes these data models have the specific structure, like the very popular lately OMOP common data model or other relational databases with defined structure. More to that, in an organization, it's not only dplyr. Sometimes there are tools, low-level, actually high-level tools, specifically written to work with the specified specified bunch of data. Yeah. More to that, the data scientist needs to share his work with the others, and he needs to do it as easily as possible. So preferably not copying the code or copying the repository, or just provide some specific state of the cohort. And and with that observation, it comes with the high entry threshold for working with the data, because we've got many tools, many data sources, and actually this is hard even for technical users. Okay, because I have an animation unintended. Great. All of this forced us, or actually we wanted to help the data scientists to by creating a general, highly customizable tool for creating the workflows. And with that, we've made many assumptions based on the feedback. Okay, so let's stay with that. So, the thing that I told, the tool should work with multiple data sources, databases, data models, and so on. The tool should be a standalone R package that you can use in your R script in order to create the cohort with the provided API. But in order to make the adoption easier, or actually the use with the work with the data much easier, we also decided to create an optional graphical user interface to the API that we developed. What's that? What's more? Reproducible R code is also very important, along with the sharing the permanently saved cohort state. So, for example, you can copy the configuration, send it to somebody else, and easily restore the whole cohort. What's more, what is useful here? Yeah, something that is working fast, and people don't want to wait. And the very specific assumption, multiple filtering steps. So usually we come with the first specific configuration for the large data, the large source data, get the result, and then continue working on very smaller data set, usually in the R memory or somewhere else. So along with that assumptions, we've created the cohortBuilder ecosystem. It comes with many packages, but I will tell you pretty soon what package is responsible for. So the first one, cohortBuilder, is providing the API for working with various data sources. It provides the standardized workflow. How does the workflow look like? So we've got two main steps. The first step is responsible for configuration of the cohort. So first step of the configuration is to define the source of the data. So for example, list of data frames, list of connections to the database, to the SQL tables, or like the REST API when the data, where we can get the data. Then with the defined source, we create the cohort object that is responsible for keeping the configuration for the cohort creation. Actually, it stores the source, but also the filters, which we can define with a filter function as a low-level cell of the configuration, which allows us to define the type of the filter and like source-specific configuration. Then, if we have the configuration ready, after these three steps, these three usage of the three functions, no computations are done at all. Only on we can trigger the computation of the data while calling the run function, and then if we want to receive the output, we just call the getData method. Optionally, we can use the many other methods like update source or add filter, update filter in order to manage the configuration. We really like this update source function because it allows you to keep the configuration untouched, but actually change quickly the source data that you want to use. So here how it works. So first we create our model is actually a list of three data tables, demographics, therapy, and diagnosis with some columns included. First, what we do is we define the source as with the setSource function. We convert the list of data frames into the TB list because it allows us to have the names of each data frame. A small thing, but useful. And then the source is passed into the cohort function along with the configuration for filters. Each filter has its own type. Currently, the cohort builder stores 5 types of filters, but it was enough for us to handle almost all of the cases that we needed. So, for example, discrete for the discrete columns, range for numeric variables, and so on. So then, after the configuration is ready, we call run, and the data is returned. Actually, the input, our assumption was also that input data has the same structure as the output data. Okay, so here, as a result, we also get the list of 3 tables. Then, if we want to replicate our workflow for the different data model, here we've got 2 tables instead of 3, where some of the columns were moved to the model 2. So this is not impressive. We just need to modify the source and the configuration accordingly to the new table names. And here we also get the structure preserved. But we also wanted to provide the possibility to work with database because this was our case. So if we now say that the model 2 is also stored in the database, we can easily change the source from TB list, so the list of data frames, into the DB tables object, which is actually the list of connections to the tables in the database. So configuration stays the same. We just switch the source. And what is very important, we load the extension cohortBuilder DB because this is actually how we wanted to handle the various sources. In order to handle a new source, we create a new extension because the cohortBuilder itself supports building many extensions. Then we quickly move our computations directly to the database. And what is pretty cool in this that no data is sourced actually to your RAM memory, the memory our environment. Everything happens on the database side. Now another extension that I wanted to mention is the graphical user interface for cohortBuilder. It's shinyCohortBuilder. So in order to, you have 2 ways to actually apply this GUI. The first approach is to call the GUI function on the cohort object. Cohort is already configured, it has some filters predefined, we call GUI, and it opens the filtering panel locally. Or if you want to inject the filtering panel based on the configured cohort in your Shiny application, you can also do it with the two functions CP UI and CP server. So this is how it looks like. If you call the GUI on the configured cohort, it will generate smartly based on the filter types the graphical version of the filters, so that you can modify the configuration over there, close the application, the one that is opened locally, and the configuration is different, so that then you can save the state, send it to somebody else, and easily share what data case do you need. So this is the GUI, but you can also have this only the panel on the left injected in your Shiny application. So what's more, with this update source, we've introduced into the cohortBuilder a hooks system. With hooks system, we can easily attach some post operations to the standard cohortBuilder operations. So for example, when we update the source, we provide first our cohort model and then new source, so that the hook that was implemented automatically re-renders the filtering panel in the graphical user interface version. So user doesn't actually need to care about writing the logic for changing the filtering panel. It does the job for you. Yeah, and here is example. Even data model 2 is local data frames, but then we switch to the database source, and it directly switches to the database. What's more, we did many steps into many optimization steps. So the whole filtering panel just pulls from the database only like kilobytes of data, because all this because we need only the statistics to render it all. Actually, we even did this with histograms. So we compute the breaks and the counts within the breaks on the database level, and we pull only this information into the panel. So I really like it. And then once more, there are some R-based features of the cohortBuilder that have also the reflection in the GUI. So I'm gonna show it now. So one of the important assumptions was to allow the user to work with multiple filtering steps. So if you want to have multiple steps, just wrap the bunch of filters into the step function, and it does the job. Then, if you want to get the data from the step, from the first step or the second step, you just provide the step ID argument to the get data function. So yeah, here we can see the data from the step number 1, and here the data from the step number 2. And it is reflected in the GUI as well. So you get the add step button, in which you can easily add a new filtering step. The data in step 2 is based on the data resulting from the step number 1. So easily you can manage the steps, create new ones, switch between the different steps configured, or even remove them. What's more, reproducible code, you can either generate, you can either call the code function, the cohort model, it will return the reproducible R code based on the backend that was used for the specific extension, or actually in terms of the standard cohortBuilder, it's dplyr. In terms of the cohortBuilder DB, in the backend you get dbplyr, so the reproducible code will be written in that in the API from cohortBuilder DB. And you can also get it directly in the panel, tools panel for the shinyCohortBuilder. Save and restore cohort state. Yeah, this is actually a very important feature for us. You can everything, like the whole API of the cohortBuilder is written in a way that you can store its configuration as a text. That's why we are allowed to store the configuration as JSON, for example. Then with the function get state, you can get the JSON, share it with somebody else, and somebody else just uses restore function for the empty cohort to get the state restored exactly. And the same you can do with Shiny. So this is our most popular case, that somebody finds an interesting case of the data, copy the configuration to somebody else just opens the application and restores it directly here. But we also support Shiny bookmark. And some of the features that are supported, that are made in order to work with graphical user interface easier. So auto filter function that analyzes the source data and suggests you what filter configuration should you use. That's why you can easily, for example, calling the GUI function, open the filtering panel on the whole data set, or all of the tables that were included in source. Run button, yes. So if you want to trigger the computations yourself while working with shinyCohortBuilder, you can enable the option. So firstly, you create the configuration, and when you want to run the computation, you just click that button. Yeah, so pretty simple. And yeah, we've got much more features that I'm not gonna describe now, but I encourage you to check the documentation. So like Shiny bookmarking that I already told you, ability to define the relations between the tables. We named it binding keys. So that, for example, if you filter one table, this will also affect the second one in the data source. Some name value mappings for columns. Nobody wants sometimes to see the IDs or like rather readable names in the filtering panel. Many tutorials in order, if you want to create your own layer or own extension for the custom source, or even want to write your custom filter. We also provide some tutorials how to do it, and some attrition plots that were also important in our cases. So what do we plan in the future? Build more advanced filters. Some of them are internally used already, but we're gonna share them soon, especially for building more complex rules for data filtering. As always, user UX improvements and performance optimization if we find some cases as well. What's more? Run job feature, so that you cannot even trigger the data computation like the run button, but you can schedule the computation to some backend job. What's more, we still haven't released cohortBuilder beta plan. For sure, we're gonna do it soon, and we're planning to add more validation for the configuration because we still see some level of improvements there. Thank you.
Thank you, Krystian.
Thank you.
All the speakers stayed on time. Thank you. Any questions, Krystian?
You say it's open source, very loud.
Yeah, it's open source, of course.
Yes, please.
Are you looking for any contribution?
Always, always, Adam. If you have some spare time and you want to not get money for that, just.
But a lot of dopamine needs to go ahead.
Yeah, a lot of dopamine. So for sure.
Any other questions?
Questions for everything clear or not clear
Yeah.
at all?
Okay, and I think we're wrapping up. Before we wrap up, we still have, I think lunch will be out there, I assume. I'm not sure if any of the organizers is here, but I'm assuming there's lunch waiting for you here. I think it only starts at 12 o'clock. But before that, I just wanted to repeat again, so that she was talking in the beginning, University of Oslo, how to teach novice learners R, make them excited and use it. Then we had Marco talk about something, a similar idea, but in a self-service manner, to teach economic students and other students at the University of Hagen. We had Guido talking about how to move R from R Markdown to Quattro fast. And then we had Camille talk about Roche templates. I'm very jealous about that. template analytics templates for all real-world evidence data, and finally we had Krystian talk about smart cohort builder. Thank you so much.
Thank you.
Then bon appétit.